world, welcome back to another Metared Stage 4 CTF 2022 write-up video. In this video, we'll be walking through some of the challenges from various categories from this CTF. Let's get into it. Now, you might be wondering why all of these are solved like this, and that's because I accidentally did all the challenges without realizing that I wasn't actually recording the video, so I pretty much have to go back and redo all of them. But it is what it is, it happens, so I'm kind of bummed that I have to go back and do all this again. But regardless, let's go ahead and start off with the general skills category, and let's begin with find a flag. Unzip this archive and find the flag named olivertwist.txt. Okay, so for this one, I have it over here in my Kali box, and you'll notice that if you unzip that archive that you download, you're gonna get this great author directory, and if you go inside of it in LS, you're gonna notice that there's more text files and more directories you can go into. Now this one does involve searching through or for hidden directories. So the way to do that with the find command is you're going to do find and then dot for current directory, tac type F, which you don't technically need, but it helps narrow down the search, and then tac iname, which is case insensitive search. And then we're going to do star.txt like so, and then tac ls. And this should pull all the txt files, regardless of whether they're located within hidden directories or not. So let's press enter. And you'll notice in the first result that our olivertwist.txt file is located in great author, adequate books, more books, .secret, deeper secrets, deep is secrets. So let's go ahead and cat that file out. And there's our first flag, Charles Dickens. So we will copy that and you'll paste it in and you'll submit it. And we're gonna move on to binary in sick. Can you see the flag in this binary? This script can help. Now all this script is an obj dump, which means we can probably just run strings on the file itself. So let's go ahead and fire up PowerShell. And let's zoom in so you can see it better. That should be good. And we're just gonna copy and paste the path to this challenge. So binary in the sixth. All right, and when you download the binary, you're gonna get this B1N or bin file. So we're just gonna copy that path and we're gonna CD into it. And then we're gonna run strings on the binary itself. And if you scroll up a bit, you're gonna find the flag right here, Mr. Robot Ethical Hackers. So we'll copy that, paste it in, submit, and we'll move on to the next one, get the flag. Inside this file, find the flag. All right, so we're just gonna navigate out of this directory, and then we're gonna go into the get the flag directory, and you're gonna see this Quinua file, and we're just gonna run strings on that as well. And you're gonna notice it's a whole lot of jargon. So what we wanna do is we wanna run strings on it, and we're gonna wanna do a find str, and then we'll do tac I for case insensitive. And for those of you who don't know, find str is basically Windows version of grep. And we're gonna look for flag like so. And it did indeed find it. Flag grep is a good tool. So obviously you could have used grep for this as well. And it would have been something very similar to what I have here. So we'll paste that in. All right, let's move on to boom files. And if we actually go to that, in here, you'll notice that it's a lot of folders and it's going to have a lot of files as well. Lucky for us, strings in Windows sysinternal suite, which is what I have linked to here. It's what I've been using for these CTS whenever I run strings in PowerShell. Lucky for us, as I was saying, it has a recursive functionality that doesn't exist with the strings utility in Linux as of yet. So how we're going to pull that off is, well, first we're going to navigate into the directory, and then we're going to run strings tac s for the recursive search, and we're going to pipe that into find str tac I, and we're going to look for the flag format itself, because if you just search for flag, it's actually going to come back with a lot of crap. Make sure to put that in quotes because the brace kind of messes up, since it's like kind of a unique character. It kind of messes up the command. Anyways, what I was saying was if you don't add the curly brace in, it's going to find a bunch of different lines from a bunch of different files that have the word flag in them, and that's not what we want. So this will still return a bunch of results, but the final result is actually going to be our flag, which is grep is magic. Now, I don't remember if this is the one or not where the F in flag needs to be lowercase. I think it might be. So if you submit that and it doesn't work, just change the capital F to a lowercase f, and that should work for you. So let's move on to the final general skills challenge titled Bag Code. Help us review this code in this file. Okay, so you're going to download the file. Let's go ahead and just open that up. Instead of opening that up, let's go ahead and just re-download it so I can show you everything I had to do to get it to work. So download anyway, bring that in there. Yes, replace. Now we're going to open this up. All right, and you're going to notice that there's some spacing issues. So let's go ahead and then fix those. And tab, of course, tab the while loop stuff. Back tab that. All right, this should be good. Okay, so what you're going to notice is that this is a basic string XORing function, and it's just XORing this encrypted flag with the key Enkidu. So we could just do this in CyberChef, but as the file name implies, it's bad code. So let's just try fixing the code. So what you want to do is you're going to want to print the flag_inc here. And then you're going to want to also comment this and this out so the error doesn't show up. Actually, I probably should have shown you the error to begin with. So let's actually show you that error. And then it's going to tell you expected a character, but string of length 16 found. And you'll see why that's the case here in a second. So now we'll comment that out and this. And what we're going to do is rerun it now with the print flagging. And you're going to notice that it's actually a tuple. So you can't XOR a tuple with, a string. And that being the case, all we really need to do is XOR it with the first value of the tuple. A tuple can have two values in it and one of them be empty. And that's exactly what's going on here. So all we really need to do is change flag_int to flag_int 0, and it'll decode the flag for us. So we can delete that debugging statement and we can re-uncomment these. And then we'll save it, of course, and we'll rerun it. And then this will be your flag. Now, it does look a little strange, I admit, and I think I originally had this solved before Anyways, that is your flag, though. So I know it looks weird, so it may throw some of you off, and you might think that there's another step, but nope, that is the flag. All right, let's move on to some cryptography, shall we? Let's start off with take my key. Suppose users Alice and Bob enter into a key agreement with P equals 101 and G equals 17. Suppose Alice chooses X equals 19 and Bob chooses Y equals 13. Determine the key they will share. All right, so I solved this one in PowerShell, or well, Python in my PowerShell terminal. And so what we're gonna do is just run Python like so. And let's go ahead and set up our variables. P equals 101, G equals 17, and P in this case, since this is a Diffie-Hellman key exchange, P is the modulus and G is the base. And then we're gonna have X equals 19 and then Y equals 13. Okay, so we need to start off with what Bob and Alice are going to be communicating to each other. So we need to do A equals the base raised to Bob's secret integer modded by 101, or the modulus. And I probably should have just used the characters there, so let's go ahead and do that to make it look prettier. So that's mod P like so. And then we can print out A to make sure we get it right, and A is 6, which is correct. So then we need to calculate, did I say Bob's secret integer earlier? I meant to say Alice's secret integer as indicated by the capital A. So now we're calculating Bob's. Apologies if I mixed that up or whatever. And we're gonna do, of course, the base again. raised to Bob's secret integer this time. And let's do y. And then we're going to do mod by the same modulus as before. And then we're going to print out Bob's integer here, which is 65. And now we just need to calculate the shared secret. And the way to do that is we're going to start off with s equals a raised to Bob's secret integer, which is 13, modded by the modulus, of course. And then if we put s, we get 14. Now, to make sure that that is the correct shared secret, we need to make sure we validate it on Bob's end as well. So let's do s equals b raised to the, and I meant to put y there, my fault, but too late now. So x mod p, like so. And then we'll print out s, and that is also 14. So 14 will be the key that they share. All right, let's move on to variables and more variables. And I can't read this, so I'll just use my little translator app. Consider an RSA system with p equals 7, q equals 11, and e equals 13. Find the corresponding plaintext c equals 17. Find the value of m, which is the variable they're using to represent the plaintext message. All right, let's start setting up our variables. P equals 7, q equals 11, e equals 13. We know n equals p times q, and that's just going to be 77. And then we also know that our totient is going to be p minus 1 times q minus 1, which should just be 60. Yep. And now we just need to calculate d, which is the inverse of e mod the totient, or phi. And then we can print out d to see what it is, 37. And now all we need to do is actually calculate m. So m is going to be equal to c raised to the d mod n, like so. And I forgot to define c, so let me go ahead and do that really quick. There we go. And now let's rerun that. And m should be 52. So your flag should be 52. All right, scrolling up to this cryptogram one right here, I believe it is in the wrong category. I believe this belongs in the cryptography category, not the exploit category. But let's take a look at it. Cryptogram. There are two cryptograms, C1 and C2, that belong to plaintext in Spanish. C1 equals da 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 da, and then C2 equals da 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 da. Indicate whether or not both cryptograms belong to a monoalphabetic substitution cipher. Type false or true. And you only get one attempt, so you got to make sure it counts. Now, there's a very easy way to determine whether these decode to the same plaintext or not. We can simply go to decode FR, and we can look for the cryptogram or monoalphabetic substitution cipher. We're going to click that, and then this is the only one that I found that actually allows you to select the language you want. Remember, it wants it in Spanish. So let's take the first one, and then we're going to just do decrypt automatically. And then you're going to notice that some of this looks like it's in Spanish, but it doesn't decode, fully well. You can try it again, and it might give you a different result that looks a little bit more like, well, a little more like Spanish. Regardless, it doesn't matter, because we're going to take a look at the second one to determine whether it decodes to something that we've seen previously here. So let's refresh so we can get the prompt back. And then we're going to decrypt our second ciphertext. And you're going to notice that this looks a little bit more like Spanish. And you can do it a couple times. But either way, you can compare these decoded results to the C1 decoded results, and they're not going to line up whatsoever. So your solution to this one is going to actually be false. All right, let's move on to find the message. And all you're going to do for this one is we're going to go to the cipher identifier, though you don't really need it, because you'll notice that the third character here, well, this is clearly in the flag format, and so it's not rotating any of the special characters. And we've seen the flag format before where the A in flag is replaced with an @ symbol. But you can go ahead and click analyze because it should give us shift and rotation as options, and it does. And so we'll click that. I already have it pasted in here from when I solved it last time. So let's go ahead and hit decrypt. And at rot 13, our flag decodes to a soldier shoots, a hacker gives enter. So copy that, paste it in, submit it, and get your points. Now then, let's move on to, I guess, the final category I really messed with in this CTF, which is the forensics category. Let's go ahead and start off with get your flag. Through tools, look for the flag in this binary. All right, so this is going to be another strings one. So let's go ahead and exit out of Python here. And then we're going to go to get your flag. Let me go ahead and pull that over there. And if you ls in here, you're going to get this binario file when you download the binary. And all we're going to do is run strings on it. Scroll up a little bit, and you'll find your flag right here. Oh, help. I actually don't do much, but I do have this flag here. And it reads, team here is your flag. And you're just going to copy that and submit it. All right, let's move on to beautiful place to visit in Peru. Do you know the beautiful places that Peru has? I'll give you some clues so you can discover them. A file has been transferred with the list of some interesting places in Peru that you should know. Find out which place we recommend you visit. Locate a clue that will lead you to discover the chosen place. And they give you a lugares.pkpng file. So let's go take a look at that. And we're going to start off with, of course, looking at our protocol hierarchy. And right off the bat, you're going to notice some FTP data being transmitted here. So what we're going to do is we're going to do file, export objects, FTP data. The file we're interested in, first of all, is this turismo.zip, because if you select it, it's going to select the packet as well. And you're going to notice over here in the hex dump that there's a flag.jpg file, which hopefully contains our flag within it, and it's not a red herring. So let's go ahead and save that to our current directory that our pkpng file is in. And then we're going to try to extract it. So let's do, whoops, didn't mean to do that. I meant to go to 7-zip and then extract here. And I think I did that. I just had a brain fart there. And it requires a password. Well, if you remember, there's also an information1.txt file we can extract. And maybe that has the password in it. So let's go ahead and save that as well. And let's crack that open and take a look at it. I have no idea what this means. So let's go to Google Translator. We're going to paste that in, detect language, password to unzip. All right, so this must be the password to unzip our file. So we'll copy that and we'll go ahead. Oh, you'll notice that flag.jpg unzipped, but it's going to be corrupted, or well, not even corrupted. It's just 0 kilobytes. So obviously that did not extract whatsoever. So let's go ahead and try extracting here again. We'll just do yes to all, paste the password in, click OK. And now you should have your flag.jpg file now, which will have your flag. So all you're going to do is go back to the challenge prompt and type in Plaza de Choque Kirao, like so, and submit. All right, let's move on to the final forensics challenge, popular Peruvian food. Peru is known for its gastronomy. Find the list of typical dishes that you must try if you dare to visit us. Identify which is the chosen dish. Locate a clue that will lead you to discover it. Okay, so let's go ahead and close some of this crap out. And I'll leave the translator app here open so that we can translate stuff later. For this challenge anyways. And now let's open up, I'm not sure why I closed that file, but let's just head back to it right here. And we're going to open up the gastronomia.pkpng file they give us. And of course, we're going to do the usual protocol hierarchy again. And this time, you're going to notice telnet. So we're going to follow that. Well, we'll apply it as a filter first, and then we're going to follow that. And then if you scroll down, you're going to notice some interesting file names here. One of them seemingly labeled as the flag. Well, I can tell you that this file name is indeed the flag. What you're going to do is you're actually going to copy and paste this section right here. And the way to realize that that is the flag, if you don't realize that the name is the flag name, you'll notice that there's this platos tipicos del per.txt here. And if you copy that and put it in the translator, typical dishes of Peru. And if you paste this seemingly food item, perhaps, if you don't know Spanish, in here as well, noodles a la huancaina. So that is definitely a dish, because we recognize noodles as a food, a very common, popular food. So this portion right here will be your flag. Don't include the flag underscore. So you're gonna paste that in, submit it like that, and there you go. I think that wraps it up for everything I was able to do during this CTF. Unfortunately, stuff at work's getting pretty hectic, and I'm in the process of getting a house as well, which will be here soon, which is why I haven't been posting as frequently. Of course, the other reason too is I was hella sick for quite a while. So, I was able to eke out those Hack the Boo videos though, so that was nice, even though my voice was messed up. But regardless, I hope you did enjoy this video with, the small amount I was able to do. So if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.